Hi guys, you're welcome to my channel. Today we are going to start the concept of physics in detail. So for those of you finding it difficult to understand physics from scratch, this course is for you. This course is specifically meant for those who want to take IGCSE and GCSE and don't really have a solid foundation in physics, or those who will be taking other area of exams that has to do with physics like WAHEC, JAMB, and so on. I want you to follow this course um, very well because I'm going to be uploading classes on it on Tuesday, Thursday, and Saturdays. So I'm going to start from a very scratch, and I want you to follow up so that you understand everything that has to do with physics. Now, when you're getting to introduce yourself to physics or you're getting to know physics, there's something that you need to have at the back of your mind. And the first thing is that why people study physics. Why study physics? Now, if you understand why people study physics, this will help you to go a long way in understanding this course of subjects. So when you ask the question, why study physics? Why people are studying it? What exactly it is that makes people say they want to study physics? If you understand this, it will let you what? Know the usefulness of physics and build your interest in it. Some people study physics for the simple reason that they find it interesting. So when you ask some people why they study physics, they let you understand that they study it because they find it interesting. Just like what Professor Watalevin says, don't just study physics because you like it. So having interest in physics is not enough reason to see the beauty of it. So if you find interest in it, you can drop it at any time that you no longer find it interesting. Because a situation whereby you study physics to the point of quantum physics, you tend to now find it kind of so abstract that you might not find it interesting any longer. So studying physics because you find it interesting should not just be the only reason why we study physics. Because physicists study matter, energy, and their interactions. When you say somebody is a physicist, that means the person study what? Matter, energy, and their interactions. They might be interested in the tiniest subatomic particles or the nature of the universe itself. So why people study matter, energy, and their interaction might be because they are so interested in the subatomic particles because they really want to know more about what? About the universe itself. Even some people, they hope to discover if there is another universe aside from this one that we know. They want to know if there is another universe other than this one that we are living in. Some people are interested to know that. But when we look at it humanly, what physicists does is that physicists study materials. Are you getting this now? When we look at it on a human scale, humanly, physicists does what? They study materials to try to predict and control their properties. Physicists, they does what? They try to study materials to try to predict and control their properties. They study the interaction of radiations with matter, including the biological materials that we human beings or animals or plants are made of. So these are some reasons why some people vent into what? Studying physics. Why some people, they don't want to just study physics. Are you getting it now? They don't just want to study physics for its own sake. Because the whole thing we just mentioned now is what physics is all about. Studying matter, energy, and their interaction, looking into the subatomic particles to know if there is another life that exists aside from that, aside from this one that we are living in. Now, but it's not just to that only. It's not just to that only, because there are some people that want to know how it can be used, perhaps in an engineering project or for medical purposes, depending on how their knowledge is applied in it. So some people, depending on the kind of physics knowledge they have, some people are very good at mechanics, some people are very good at what's it called, um mathematical physics, and some people are very good in medical physics and so on like that. So based on their own knowledge, they also use physics to solve a particular problem. So that's the reason why some people are studying it. Are you getting it now? Why some people study physics as part of their courses? Because they want to become some other type of scientist. Are you getting it now? Those people wants to be a chemist, biologist, geologist. Those people, they are not a physicist, but they study physics because they need physics to do well in their field. There are some field like chemists. If you study chemistry, you need some area of physics. You need to understand some areas of physics because that particular course depends on some area of physics. Biologist, some parts of biology depends on physics. Geologist, some part of it, not even like when it even comes to geologies, it's not even some part of it. Are you getting this now? You look into physics more even than the biologist. So some people are studying physics because the course that they are doing has to do with physics. When you look at somebody doing engineering now, so like it's more or less as if they are also studying physics and mathematics, because a lot of areas of their field has to do what with physics. It depends on physics. That's why they study it. They are not studying it because they want to become a physicist, but they study it because they need it in their own field. So these are reasons why people study physics. So you as a person, you need to first of all ask yourself, oh, why am I studying physics? Am I studying this physics because I have interest in it? Am I studying it because I want to be a physicist so that I'll be able to look into matter deeply, energy and their interaction, and at the same time look into the subatomic particles, the proton, neutron, the electron, and try to discover if there is another universe other than the one that we are in? Or you want to study physics so that you can apply the knowledge of physics to an engineering, to human biology, and so like that. Or you are studying physics because your course has to do with some knowledge of physics. Maybe you are studying chemistry, you're studying biology, you're studying geology, and so on, like even geophysics or geography. Are you getting it now? So is that the reason why you are studying physics? So you need to understand this so that you are going to prepare in accordance with why you are starting. I hope you are getting this, because some people get discouraged when they see another person, the way they handle their own physics. Why? Somebody like chemist. If the person like chemist handle physics, it can be like somebody who wants to be a physicist. They have different interest. A chemist only need it for a while. Are you getting it now? A physicist need it till forever. So they are going to handle it differently. So all the branches of science draw great deal on ideas from physics, and physics may also draw on them. So when you talk about science, all areas of science, they draw a very huge ideas in physics, and physics also draw idea from some areas. For example, mathematics, chemistry, physics draw idea from them. So it's very important we understand this better. Now, when you understand why you study physics or why we study physics, the next thing you need to understand is how to think physics, that is thinking physics. Now when it comes to Thinking physicist. The question you should ask yourself here is that how do physicists think? How do physicists how do physicists think? So you need to understand how they think. One of the characteristics of physicists is that they try to simplify problems. So most times when you are given a question to handle, or somebody asks you questions, as a physicist, you must know how to simplify that particular problem, because it's one of the great characteristics of a physicist. We try to simplify problems, reduce them to their very basic. So anything physicists think, they are thinking majorly on how to simplify a problem to the very basic. So if they're able to solve it, simplify it to the very basic, then they solve them by applying some very fundamental ideas. Are you getting where I'm coming from now? For example, now you are familiar with the idea that matter is made up of tiny particles that attract and repel each other and move about. So when you say matter, you are aware that it's made up of proton, electron, and neutron. This you are familiar with very well. So you're familiar with how proton and proton will repel. You're familiar with how electron and electron will repel. You're familiar with how electron is revolving around the nucleus, and you're familiar with how proton and neutron, how they are the one that made up the nucleus. You're familiar with how the whole of the mass of an atom concentrated at the nucleus. So you are familiar with how tiny all these particles are. So knowing this is very powerful idea. Knowing this is what? Is a very powerful idea, which has helped physicists, or even myself and you, to understand the behavior of matter, how sound travels, how electricity flow, and so on. So understanding this has really give us a lot of things, what we refer to as a fundamental idea. So as a physicist, when you handle a problem, you think on how to simplify that problem. When you simplify that problem to the very basic, that basic that you simplify it to, we refer it to fundamental. So once a fundamental idea is established, physicists look around for other areas where it might help to solve problems. So once you establish what a fundamental idea, for example, now we established a fundamental idea that proton and proton will repel each other, electron and electron will repel each other, the proton and electron would attract each other. That is a fundamental. That fundamental will now look into where it will be a useful something, and that is how physicists think. So we look into this and look at the universe. So looking at proton and electrons, these particles has helped us to understand how the universe is expanding. You just wake up, just check and take a look at the map of the world. You see that when you look at a particular country and another country, when you look at especially the very close one, when you look at what their shape look like, you see that this thing can fuse into each other. Just take a look at your map very well. You see what I'm trying to talk about. And that's an idea that the universe itself is expanding, what we refer to as the Big Bang. The Big Bang theory. So when you look at all of this, we understand all these things just because we have understand the basic idea, the fundamental idea of the universe itself. Because anything that exists on earth is referred to be a matter. And every matter are made up of proton, electron, and neutron. These are basic. These are fundamental. This fundamental is what we now understand that help us to come up with some other theories that help us to come up with some understanding about the universe itself. So the more you study physics, the more you will come to realize how the ideas join up. Also, physics is still expanding. Absolutely, many physicists work in economics and finance. So the fields you see today is still going beyond that, because we now have some physicists that they are working on economics and finance, trying to use the idea of physics to predict how markets will change. Trying to use what? The idea of physics to see how what? The market will change. Other uses their understanding of particles in motion to predict how traffic will flow. So the fundamental idea they have in motion, they want to see how we can use it to control traffic or to predict traffic. So it's very important to understand this. Very, very what? Important. Or how people will move in crowded spaces. All of these things is what we are applying the knowledge of physics for. So it's very important you understand this. So, but when you look at all of these things we've said, we must understand the backbone of physics. We must understand the backbone of physics. So, because if somebody break your backbone, of course, you know what is going to cause. It will reduce your efficiency drastically. So, the backbone for physics is mathematics. Yeah, physics rely basically on mathematics, and that's why the most robust area of mathematics is being invented by physicists. So because it helps us in analyzing all our data. So because majorly physicists measure quantities and process their data. Are you getting it now? So that is the backbone for physics. Although today computer has allowed physics to be very simple to study, because we can now use computer to access some of our instruments to extract data from those instruments, such as the spacecraft, the telescope, all of those things. We can now what? Attach them to computer and extract information other than what it used to be before. Lastly, when you choose to be a physicist, you choose to study physics either as part of your course or as your major, then you are into two things. Are we together now? You are into what? Two things. The first thing is that you're joining in with a big human project, learning more about the world around us. Are you getting this now? You are trying to learn more about the world around us, just more than literal stuff that every individual see. And you also want to start applying that knowledge to solve what? The world problem. That's the first thing. You want to see beyond what every normal human see. When you say you want to study physics, you want to look at a room and say something different from what any other person that is not a physicist will say. And then that knowledge that you bring from that, you want to use this to solve a particular problem. And secondly, you will be learning to think like a physicist, how to apply some basic ideas, how to look critical at data, and how to recognize underlying patterns. Whatever you aim, these ideas can stay with you throughout your life. So this is going to be the very basic introduction to this particular course. So by God's grace, in our next class, we're going to start by looking at general physics. So, and when you talk about general physics, we are starting from the concept of making measurements. So we look at the concept of making measurements. We describe motion, force and motion, turning effect of forces, forces and matter, energy transformation and energy transfers, energy resources, work and power, and that is the whole of the concept of general physics. Then we now move to thermal physics, where we are going to be talking about the kinetic model of matter, thermal properties of matter, thermal energy transfer. Then we are going to look at physics of waves. So under the physics of waves, we look at sound, we look at light, we look at the properties of wave, we look at spectra. Then we move to electricity and magnetism. So magnetism, static electricity, electrical quantities, electrical circuits, electromagnetic force, electromagnetic induction. Then we'll move to the fifth part of the course, where we're going to talk about atomic physics, the nuclear atom, the radioactivity. So all of these are what you are going to be learning in this course. Thank you guys for staying to this time. See you in the next one.